Hello and welcome to this video. In this video we're going to be looking at the topic of power in electricity. So this is going to be the final video on electricity, and hopefully up to now everything has been okay. Power is going to be quite a simple end to this section of the course. We might have, you should have definitely met power at GCSE, but probably not in as much detail as we're about to go through. So if you remember from GCSE, generally when we're talking about power, we say that power is just the rate of energy transfer. Okay, the rate of energy transfer. Okay, meaning that if we wanted to write an equation for this, we would say it is the energy transferred over time, or the way we would see it on the formula sheet written is that it's the work done over time. And we'll have a look at what work done is when we look at the mechanics topic. But work done is identical to saying it's the amount of energy transferred. Okay. So if power is the energy that we're transferring per second, how can we work that out based on what we can measure? So what we know we can measure definitely using ammeters and voltmeters are we can measure current, which we've already defined as being the charge over time, and we can measure the potential difference, which we've defined as being W, or the work done per unit charge. Now, how do we get W over T out of Q over T and W over Q? Well, if we multiply them together, if we do V multiplied by I, we get Q over T multiplied by W over Q. The Q's will cancel, and then we get W over T. And what this means is that one expression we could have for power in terms of electricity is power is the potential multiplied by the current, okay, or the current multiplied by the potential. Either way, it's multiplication, doesn't matter what order, okay. This isn't the only thing that we have for power, however, but this is probably the most common one because this allows you to be able to measure these two things, and then after measuring them, you can therefore work out how much energy is being transferred in that component per second. But what if in the question we weren't given the potential, but we were given the resistance? Well, you could say, I could work out, you were given the current and the resistance. You could say, well, I know V is I over R, or V is I times R even. V is IR, so I could just get these two values, multiply them together, and then multiply by the current, and that would give you power as well. So another thing we could do is substitute this expression for V into this equation and say that this is actually equal to I squared times R, okay, and this is your second equation. And then we could have also said, what if they give you the potential and the resistance, but they don't give you the current? Well, the current we know is V over R, so if I substitute that in, I can get that power is V squared over R, and this is your third equation for the power. So, as an example, if I had a component of some resistance of 3 ohms and it had 2 amps traveling through it, we might ask, what's the power across this? Well, we've been given a resistance and a current, so we choose which one includes resistance and current. It's going to be this one. So the power across here is the current 2 squared times by 3. 2 squared is 4 times by 3 gives you 12, and power is measured in units of watts. Okay, now 1 watt, if we think about this, could also be referred to as joules per second. So 1 watt is equal to 1 joule per second, but we tend to go for watts. That would be what we'd call the SI unit, and joules per second would be the base SI unit. So if we were to break it down, actually we could probably go further than that to get the base SI unit by breaking down joules, but this would be what we'd get if we looked at just the equation by itself. But these two things are identical to each other. In terms of questions they'll ask you about power, they'll tend to ask you mostly to just calculate the power output. They might ask you things like, how would the power output change if this thing happened in the circuit, in which case you would just have to go through your Kirchhoff's laws or Ohm's law to try and figure out how the potential or the current would change, and that is then going to tell you how the power is going to change, because they're directly proportional. If we have more current, we have more power. If we have more potential, we have more power. Okay, so this is quite a nice, easy section of the of electricity. You would have already met this at GCSE, this P equals VI, but probably not these other two, but they're just different ways of being able to calculate the exact same thing. So this is power. Thank you for watching.